to the introductory talk on Docker. As mentioned, my name is Amjith. I go by Amjith on Twitter. I work for a company called Relic, and we do performance monitoring. To basically, you install our software on your server, we collect metrics, we show you graphs on how the performance is and all that stuff. And that's not just a product pitch. I'm actually setting up the stage for where we use Docker in our company and how it solves a very unique problem that we encounter. But before we get into any of that stuff, I want to set the stage for why is this useful? Why should you even be listening about Docker? So here's a typical web application stack. You have your front-end server, Apache or Nginx, and then you have your application server like UWS GI, MongoDB, or something, and then you run your Django application on top of that. Well, in addition to that, you have your Postgres or MySQL database, and then a cache like Redis or Celery for doing background tasks. And of course, being from New Relic, you use New Relic for monitoring all these things. If you are a full stack developer, you might be modifying any of these places. So what I'm trying to say is, like, you could be changing something in the Django application code, or you could be modifying the Apache config, or tuning your Redis, or changing something on your Postgres. And come deploy time, you run all of your integration tests, you make sure it runs locally on your box, and everything works great, and then you roll it out to production. And then, half an hour later, you figure out that your customers are not able to pay, so you hurriedly, roll back everything, and then you're trying to figure out and you're trying to debug this problem. You try to exactly match the, the minor version of Python on your development machine and the production machine, and, looking at log files, pouring over them, and only to find out that you forgot to set this environment variable in production because, you switched the credit card processor or something, which is not typical deployment process. Has this ever happened to anyone? Oh, good. I'm not the only one. Well, anyway, so Docker tries to solve this in a very unique way, which is whatever system that you develop in, including the binaries, the libraries, the Python minimum, the minor version of Python, the supporting libraries and the Postgres and all that stuff, bit by bit, that exact same image, the exact same binary and libraries will be the one that actually runs in production. And we're going to see exactly how that's going to happen. Okay, so now that I've set the stage, I want to explain what Docker is. Docker is this pant company that produces trousers. Clearly, I'm not here to talk about that. So many disappointed faces. Gosh. Okay, so just to give a tip, you put them one leg at a time. And unless you're Superman, please wear the underwear inside, not outside. All right, joking enough. The history of Docker is it started in 2013 by a company called .cloud. And it's written in Go, and it has a very active community. It's an open source project. And the community is so successful, and the project is so wildly successful that the company actually changed its name from .cloud to Docker. So it's a very active project, even though it's sort of young. If you know, well, this is the definition that comes straight out of their website, which says Docker is an open source engine that allows you to automate the deployment of any application as a lightweight, portable, self-sufficient container that will run virtually anywhere. I put the asterisks there because when they say anywhere, they mean Linux machines. So if you know anything about chroot or BSD jails, then Docker is a similar technology. It is a sandboxing technique that allows you to run a process in a sandbox. And for this, it uses Linux containers. Linux containers are part of the mainline Linux kernel for about 5 years now, so it is a very mature and stable technology. And Docker merely sits on top of this and makes it easy for you to work with these containers. And in addition to just sandboxing, it also provides some additional features like a layering file system called AUFS. We'll see more into why that's useful in just a few slides. And a minimal Git-like versioning system, and a REST API that you can talk to the daemon with, so it's easy to control it. So, up until now, I've been talking about sandboxing and running it in a virtualized environment and so on. And so how does it compare with existing virtual machines? So if you have your bare metal on which you run your host operating system, you install VMware or VirtualBox, which is your hypervisor layer. And inside of that, you install your guest operating system, which could be Ubuntu or CentOS or whatever it is. And then you install all the necessary packages like Python or Django and Cyclepg2 and Postgres and so on, and then you run an app inside of that. If you need another instance of this, you need to go through the same process. I mean, you can take a copy of that VM and run again, but it includes the whole stack. It needs the whole guest operating system, another copy of that, another copy of all the libraries, and so on. To contrast that with a Docker, on a bare metal, you run your host operating system, which in this case has to be Linux. And Docker is not a hypervisor layer. It sits as a daemon that runs on your Linux machine, and you have images, which are a collection of libraries and binaries that are needed in order to run your program. And when you launch multiple instances of this image, they're called containers, they actually share the underlying files until you actually start to modify them. Then it makes a copy on write snapshot of that, of the deltas, so you're not impinging or interfering with the other containers. So there's a lot of sharing going on, and it still provides you the sandbox, where inside of the virtual machine, it looks as if you're still running from inside the VM. So it's lightweight because you don't have an extra copy of operating system on every container. It provides you isolated instances using Linux containers, and it is faster than VMs. It actually shares the underlying kernel of your host OS, since it's both Linux. And typically it boots up. When you launch a container, it starts up in milliseconds, if not under 1 second in most cases. So I'm going to show. Well, I mentioned that in order to run Docker, you need Linux machine, but I'm going to show some demo on my OS X box, and I want to go over the setup that I have in order to kind of explain how I'm doing this. But this is not a slide about how to install Docker. They do a very good job of documenting how to install Docker on different platforms. So docs.docker.io is a great resource for that. So if you're running Linux on your laptop, then or your host machine, then you run Docker daemon, you install Docker, and it provides you with two components, the Docker daemon and a Docker client. The Docker daemon runs, and then you use the Docker client to interact with the daemon, and then you launch containers that run on your Linux box. If you're on OS X, I have to have a virtualization in order to run the Linux. So I use VirtualBox, and then inside of that I run Linux, and inside of that I run the Docker daemon, and that spawns different containers. But I still get the OS X client, so the client is actually living on my OS X box, and that allows me to talk to the Docker daemon that's inside of the VirtualBox. But this is only for development settings. I mean, in production, I presume that you're all running your production apps in Linux, so you're not going to have this extra layer of hypervisor on top of that. Okay, so that's that. I threw a couple of terminologies. So the Docker daemon is the server component, and the Docker client is the client component. And talked about how if you run the Docker daemon and the Docker client in the same machine, then you can use the client to talk to the Docker daemon. And that's done using a Unix socket. And that is the most secure way to interact with Docker. But if you're inside of a virtual VPN or VPC, then you can choose to run your Docker daemon that listens on a TCP socket, and so you can use any of the remote machines to contact the Docker daemon and run multiple commands on or ask the daemon to run different commands on it using that TCP socket. So there are Docker clients available for Linux and for OS X, so you could use one of those. Okay, I think it's time for a demo. Okay. I'm going to do a Docker version, and we see that I'm running Docker 0.9.1. And this is not the latest version, but there's a server component. The daemon is running 0.9.1, and the client is running 0.9.1. I'm going to pull an image so we can start playing with it. I'm going to get that started, and while that's happening, I want to go over a couple more terminologies here. What I'm doing there is, image is a read-only snapshot that has your binary and your libraries, and a container is an instantiation of the image. what I mean by that is, let's say you're working on your master's thesis or senior thesis, and you're writing your, you spend 2 years researching all of your stuff, you typed out your master's thesis, and letter by letter, word by word, you type them all out, and you're ready now to give it to your professor. When you want another copy to send it to your professor, you're not going to sit there and type your master's thesis all over again. You're just going to merely take a photocopy of that and give it to your professor. And when your professor wants to make notes on it, either he highlights some passages or writes margin notes and corrections on it. Those corrections and margin notes are localized to his photocopy, and it's not going to translate back to your master copy. And so when a third professor requests it, you can take another photocopy from the master copy, and it won't have any of those changes that are made in the photocopy. So that is the idea behind images and containers. So an image is something that you build by installing different libraries, different binaries, whatever it is that you need, adding files, your project files, and so on. And when you want to run your application, you instantiate a container that is a snapshot of that image. And when it starts running, it might produce log files. You might have to change an environment variable depending on your container. And those changes are localized to that container only. It's not going to translate back to the image, or it's not going to interfere with the other containers that are running concurrently. And I briefly mentioned the registry. The registry is like a Python package index equivalent for Docker images. It is a publicly, openly available index where people can push images and others can look at the image and then pull it from the image, and it's a way of sharing the images. And a repository is a collection of all these projects. So you can have a local repository where you have a bunch of images, or you can have a repository on the registry. So it's kind of like if GitHub is your registry, then your project in GitHub is the repository. Okay. I'm going to get back to the demo there. So the base image just got pulled, and it's ready for me to start playing with. Let's see what I have. So I can look at the images that are currently in my local repository by running Docker images. And even though I pulled a single image, it actually pulled 4, or it shows me 4. It's technically just a single image. As you can see, the image IDs all match for all 4 of them. It just happens to have different tags. Somebody just tagged it with like latest Ubuntu and Ubuntu Quantal and typo with Ubuntu Quantal and so on. So if I wanted to launch well, before we launch a container, I'm going to run Docker PS, and this allows me to see what are the containers that are currently running. And since I just barely started, there are no containers that are actually running, and so Docker PS gives me nothing. So let's launch a container and see what it does. So that's the way to launch a container. So you basically say Docker run, give it an image name, and then a program after that tells you that this is the program that I want to run inside of the container. And the base image basically has absolutely nothing. It's a very bare minimum set of files that are necessary in order to get a container up and running. So when I run echo hello, it'll have the basic shell, and it prints out hello. That hello will actually run inside of the container, and stdout just happens to got spit out into the same terminal that I'm on currently. If I run Docker PS, I still get nothing. The reason for that is because as soon as the command is finished, the container stops. It doesn't have any function anymore. And so Docker PS only gives you the list of containers that are currently active and running. And so since that container finished, it's not showing up here. Let's run something a little bit larger. So let's do a longer one. So we can do while loop. In this while loop, it basically just sleeps for a second and then it just continues to print. Sorry about the changes there. Sorry, the visibility on the terminal. So again, I ran it in the foreground mode, and so that hello kept printing, and so until I pressed Control-C, that was happening inside of the container, and the stdout was getting piped into the TTY. And since I pressed Control-C, and that terminates my command, and thus stopping my container. Another way to run this is a daemon mode, which is you run a command and then you say run it in a background mode, so it's not occupying my current terminal, so it frees up my current terminal to do other things. So I run Docker run -d, give it the base name, give it the image name, and then whatever command I want after that. In this case, when I run this, I get a SHA ID back. And that's the SHA ID of the container that is currently running in the background. So now if I were to run Docker PS, I get something in the output that says, this is the SHA ID, and this is the command that's currently being run, and this is the image from which the container was launched, and so on. Let's copy that. And if I run Docker logs, and it hits that one, it prints the std out that's currently running inside of the container. So this is how you can inspect the container that's currently running, and you have access to the logs from that container. So whatever is being printed in std out, you can look at it through the Docker logs. So there's another way of running this. This is called interactive mode. So I have an image, and I want to do more than just one command. I want to install some things inside of that and make modifications, set in random variables or something. I want to work on it interactively, and the way to do that is you basically give two command line switches, the -I and the -T. The -I stands for interactive mode, and -T is attach my current terminal to the TTY of the container that I'm about to launch. And the shell to use that is the bash shell. When I launch this, you'll see that the prompt changed, and I'm put inside the container as a root user. The reason I get the root user privileges inside of the container is because, again, the container is an absolute sandbox. From inside of the container, you cannot damage things that are running on the host operating system. So if I run ls, I get a full file system of as if I'm inside of a virtual machine, and I get the root access inside of the container. But if I run ps, the only two processes that are running are the ps that I ran and the bash command with which I launched. So there's absolutely nothing running. There's not even any daemons. There's no SSH daemon. None of that stuff. So this is a bare minimal VM, if you will, that allows you to sandbox a single process and not have other extraneous things that are running on your system. That's what makes it lightweight. So let's install a couple of things. Let's modify things here just to see how this will work out. Let's install a few, premier Linux applications so we can actually get some work done. So Fortune and Cowsay will give you exactly what you need. Okay. So now I'm going to launch Fortune, type Cowsay, so we can, get something useful, like a cow telling us to eat pork. So now I've installed a couple of programs inside of a container. Let's exit out of this. I'm actually going to copy that SHA ID. For later users, I'll tell you why in just a minute. Now I've exited out of this. If I run Docker ps, that container that I finished, again, it stopped running the bash program that I asked it to run, and so it's not shown in the list. Although I do see that I'm still running my the infinite loop, so let's stop that. So that's the way you can stop a container that's running. So now if I run Docker ps, I get nothing. So I've just stopped that container that is running. So now, let's do Docker images. I still have the base image, so I'm going to launch another container from this base image, just because. And in the interactive mode, and see if I have that Fortune available for me in this container. It does not. The reason was because when I installed those programs in a container, it was localized to just that container. It is not available for the base image or other containers launched from that base image. So that's what I was trying to show there. So exit out of that. Now, this is why I copied the SHA ID. You painstakingly installed a bunch of programs inside of a container. Now you want to save all those changes and make a new image out of it. Let's say, for example, you've installed Django and Python and Cypress inside of a container, and you're about to launch it, and you want that image to be available for you for launching multiple containers out of it. Then this is the way you can do this. So you say Docker commit, and then give it the SHA ID of the container, and give it a name. I'm calling mine Fortune Cow. Now, if I run Docker images, I'll see the new image listed in my list of repositories. So there's the fortunate how the image ID is different from the base because there are a couple of new programs installed. So the SHA is different. Now, if I run this in interactive mode, and ask it to tell me a fortune, this is actually going to tell me a fortune. There it is. So now that I've installed it, now that I have a new container from the image, anyway, you get the idea. Okay. So with all of those, now I've made an image. How do I share it with other people? So this is where the registry comes in handy. I can take this image and push it to the registry. In order to push it to the registry, I need to name my image with my username. And so the username says, Docker tag, I'm tagging my fortunate cow as Amjith/base scores. And Amjith is the username in the repository that I've already set up, or in the public registry that I've already set up. So I tag that, and now if I run Docker images, I'll see a new entry in my Docker images that says fortunate cow/base scores, both of them with the same image ID. Now if I were to run a Docker push, that gets it pushed to and that gets pushed to the Docker image. So this is the Docker image, the HiPy equivalent that I mentioned. And if I were to push it, it gets pushed right there. So if you want, you can now actually pull this image and play with the fortune and the cow say like although I would not recommend pulling it now because of the bandwidth restrictions, so please don't. Okay. I think that concludes the first demo that I wanted to do. So the basics that we've learned so far are you can pull an image from the registry using Docker pull, list all the images using Docker images, launch a container using the run command, look at all the containers, look at all the logs of a particular container. We also saw some stop command that allows you to stop a particular container and so on. Okay, so far we saw how to build an image by hand, which is install each program by hand, one after the other, and then create an image and comment that and push it and so on. If you wanted to automate this, because we're all programmers, so that's what we do. There is a facility called Docker file, which is just a series of commands that allows you to build up to an image. This is an example. It's a very simple example. What this says is use my base image as the base. And the second line there says set an environment variable called test_env, set it to true. And add is another keyword that allows me to add a file from my local host operating system into this image, into a specific path. In this case, I'm just putting it directly in this image because, when I'm building the image, I'm given the root privileges so I can put files anywhere I want. And then I'm running apt-get updates and installing the two Premium programs that I talked about. The last line is actually important in this one. It's actually interesting in this one because typically whenever you launch a container, like I mentioned, you run docker run, give it an image name, and then the program that you want to run inside of the container. If you omit the program name, that is, if you're not going to give a program name as part of the command line when you're launching it, then this is the default command that it will automatically run. So let's look how to build an image out of this. So that is my Docker file that I just showed you. So there's the base, and I'm adding an environment variable, adding some test files, running apt-get install, and my command here is fortune getting pipes to pass it. The way you build an image is like that. So you say docker build, give it the resulting file's image name. So your -t says that this is the name of the image that results from running a Docker file or building from a Docker file. And the Docker file is located in my current folder, so I do it just a dot. And that goes through and runs the apt-get update, apt-get install, and all of that stuff. And now it should be available for me. If I run Docker images, there's our base scores, the first entry in that list. The image ID is slightly different from the Fortinet cow because I've set the environment variable and I've added another extra file, but if I had not, then it would exactly be the same. The resulting images should be the same thing. Just to see how that run works, so I'm launching a container, I'm not giving it a command, so it's going to automatically use the command that I gave as a default in the Docker file. And that's a nice way to end the demo. Okay. Okay, so far we've been just playing with some toy applications in Linux. If we wanted to run get some real work done, that is, run a Django application inside of a container, then we typically have a Django application that's listening on a particular port, say 8000. But that port is actually localized to just that container. It is not available to the outside world. In order to make it available to the outside world, the way we do that is using port forwarding, and it's actually trivially simple. When you're launching the container, add a -p switch, and then give it a mapping that says, this is my host port to which I want to connect my containers port. And then you launch your image, you might have built it with a Docker file with a command set to run server. And this will automatically launch your Django application, connect the port 8000 of the container to the port 8000 of your host, and now you can hit the 8000 on your machine, and you can automatically see your Django application's operation happening. So that's port forwarding, basic networking stuff. There are a couple of features that I wanted to go over, which is volumes and links. So volumes is how you mount folders. It's sharing of files between your host operating system and your container. So you can map your host path, a particular folder from your host machine, into your container, and whatever changes you make in the container in that particular folder will be available on your host, and whatever changes you make in the host will be immediately visible on the container as well. And you can mount it in multiple ways. I'm not going into the details of this particular, the other options of this particular feature, which is, you can say read-only mounting, so the container can only read from that folder, but the host can keep writing to it and so on. And links is a simple service discovery. So service discovery idea is, let's say that you have a container that is running MySQL or Postgres, and another container that is actually running a Django application. And a Django application has to know the host name and the port ID of your Postgres app, or of the Postgres instance, in order to talk to it. And every time you launch a container from an image, the IP address on the port are assigned randomly. So getting them to talk to each other is a pretty hard problem. And so the link one allows you to say that I have a MySQL container that is running. I'm going to give the command --link MySQL, and I'm going to launch my Django container. And what it does is, when it launches the Django container, Docker will automatically inject the host name, the port of the exposed of the MySQL container automatically into your Django container. And so you just have to write your Django application in a way so it'll read from the environment variables instead of having it hard-coded in your settings files to automatically read where to go for a particular database. So those are the features, and then I briefly mentioned that there is a REST API. So Docker daemon is also a server that listens on a particular port, and there's a REST API with just a simple curl command. You can pretty much do all the stuff that I did in the terminal. List all the images, list all the currently running containers, create them, start them, stop them, and so on. And that's exactly what this project called Shipyard does, which is a Django application. Here's a screenshot of that. And what this does is it allows you to interact with Docker from a web browser. So when you run Shipyard, you can look at all the containers that are currently running on your machine, the images that are currently available on your machine, and it uses WebSockets. So you know how we saw Docker logs to see the STD out? You can actually attach to a container from the web browser, and using WebSockets, you can look at the logs that are actually scrolling through in your container. So it's a really interesting project that very useful. Okay, so coming back to how we use New Relic, how we use Docker at New Relic. So I mentioned that we monitor applications and collect metrics out of different web applications. For this, we have to add instrumentation for a bunch of different web frameworks, a ton of different databases, and this is just a list of all the different libraries that we have instrumentation for. So what this does is, excuse me, what this does is, it makes running integration tests almost impossible. Because if I wanted to run an integration test where I'm trying to test my Postgres instrumentation, then I have to have different versions of Postgres installed on my machine. And say I want to suddenly see how this affects MySQL, then I have to have different versions of MySQL installed on the machine, and so on. And so this was very difficult before Docker. And after Docker, what has happened is we created images for all these different instances that we wanted to test and run our integration tests against. And so now, I just have a container that is always running MySQL instance, a container that runs Postgres, a container for Memcache, Gearman, and Redis, and a bunch of different things. Now, I have a bunch of integration tests for Django, and I launch my Django integration test inside of a container, and using the links feature, I can automatically get the IP address and the port of all the different databases. And for each test, I have written it in such a way that it will read from the environment variable, and so I don't ever have to worry about what is the current IP address or anything. And so links will automatically do the service discovery for me. And now I can run all of my integration tests, both in my laptop as well as on Jenkins or anything. And this helps us a bunch because we don't just support Django, we also support a bunch of other web frameworks. And so all I have to do is launch containers in parallel, and now I can run integration tests for each one. This actually cut down our Jenkins test builds by 1/4 the time that it used to take. So that's how we use that. Coming back to the original problem. We talked about this typical web application stack, and you could be changing anywhere. The idea is put them inside containers, and now you will be modifying a particular image in order to add an environment variable. And after you've added it, you're confident enough that it is going to be available on the production machine. So as long as it runs locally, it will also run in production. And there are different ideas behind this. One, you can develop inside of a container in the dev box, push it directly to prod. Or you can have a registry, like this registry that I talked about, it doesn't have to be public. The registry can be a private registry where you can locally host it, a registry version. So if you go to GitHub and search for Docker registry, there is a Flask project that allows you to run a private registry locally on your machine. Or there are other commercial options like Quay.io and so on that allows you to do private registries, to which you can then push your image that you've developed, promote it to the next level, which is running tests on that image, and then promote it to the next level, which is move it to staging, and then finally push it to production. It'll be the exact same image that you created on your dev box that gets promoted into all of these different stages. So I think that kind of brings my talk to the end. The Docker.io is a very good resource for all the documentation that Docker has to provide. Very friendly community. You can go to Freenode, pound Docker, and there are always lots of people there. Very helpful folks. Okay, I don't know if anyone was here. Well, I know a lot of you were here for the lightning talk yesterday, but if you were not, then the demo that I did was not actually live. It was pre-recorded. It was using Played Against Sam. This is an awesome tool for live demos. So, anyway.
Thank you very much. We have 5 minutes for questions.
Thank you so much, Amjith. I like to talk. I love Docker, and I want to use it a lot more. I think some people may have pounced on the links aspect. Links work when you initiate your machines in a particular order, and I think that the answer that some people may have sort of raised in requirements or any question how you discover other Docker instances in your environment that may actually come along later than when your latest service was started, was launched. And the answer to that is etcd. So perhaps it's something if you have a moment, you can talk about that.
Okay. etcd is a key value store that allows you to do service discovery. So, like it was mentioned, you have to launch, in order to use the links feature, you have to launch these containers in a specific order. You have to have a database container launched first so that the host and the port are available, and then launch your application container so it can automatically inject those values into the environment variable. Whereas if you don't want to care about this particular order and you want to launch containers in a different set of order or something, then you can use etcd. etcd is a centralized place in which it stores different services and then their corresponding values. These values can be anything, and this could be a host name, a port ID, and anything that is associated with a particular key. And whenever a container comes up, it can automatically register itself with etcd, and then whichever container is still waiting for a service to come up can query the etcd and get automatically notified whenever a value changes. So that is another very good service discovery project. If you are familiar with Zookeeper, then it is a simpler, easier to use version of Zoo.
Would you consider or even recommend Docker as a replacement for Vagrant for local development? I mean, on a Mac, you will still have to run it inside the VM, but it seems to overlap a lot of functionality you would use it for.
I don't think Vagrant and Docker, they're complementary, I would say. They're not trying to replace each other. Vagrant serves a different purpose, which is automating virtual machines, and Docker allows you to sandbox single applications. So it is actually recommended not to run your application or database inside of a single container. You want separate containers for each one of your processes. But you wouldn't want to do that in a virtual machine. The virtual machine would probably have the database and your app running in the same virtual machine. Sometimes they're different. So they serve different purposes, I think, and they're very complementary to each other. For development purposes, I would, on a Mac, so the boot to Docker thing that I showed you, how I run this, it still uses Vagrant in order to launch me and then get it up and running. So I think those are complementary technologies. Thanks.
Thanks for the talk. I've never used Docker before, but I will certainly try it out. You mentioned before you use settings or environment settings for your different combinations of tests. Have you tried it out with Django configurations? All those settings are fun.
Django configurations for
the Django setup. So you somehow have to tell Django where your database lives. And how do you said you use settings or environment variables? How do you use them? Do you use Django configurations? Or have you any experience using Django configurations in this place?
I have not used Django configuration. Since we are writing these for different frameworks, so these integration tests run not just on Django, but also Cherry Pie, Flask, and all the other frameworks. So we basically just read directly from the environment where we can just start.get and then populate the fields for database and port and so on. So that's definitely something that's worth checking out. I can take a look at it.
Thanks.
Thank you.
Hi, thank you for a great introduction. I've played a little bit with Docker. I was wondering if you have a recommendation about the configuration. If I have my Docker file, should I bake configuration into the image I'm creating? Or should I put it in a volume that I mount externally? For example, if I have an Nginx running SQL, do I put the certificate and private key inside the image, or should I keep it outside?
I don't have a recommendation specifically for the certificates because I'm not very good at the security part of things. But the way that we've used typically is we have so one of the things that configuration that I use is requirements.txt in order to set it up and create a virtual environment and so on. And I typically just add it into the image as part of the repository, and then I run all of my commands after the file gets added into the image. So I have not used. I've typically only used volumes if I'm doing things such as database, like a database instance that is running inside of a container, but it writes to an actual volume because the AUFS, the layering file system, is notoriously slow for write-heavy operations. And so if you're running a database inside of a container, then running a database in the container, that's totally fine, your database instance, but your data file should be written to a volume that's mapped to the host operating system. So it's not taking a really long time. So,
Thank you.
Thank you for a great talk. I have a question. Do you see the advantages and disadvantages comparing the approach you showed in pushing your containers to staging production as opposed to using a server provisioning setups like Puppet or similar packages?
It alleviated some of the Puppet requirements. So Puppet configurations are not as notorious as it used to before, since Docker allows you to build images where dependencies are all built in and you have the right versions built in and so on. But we still use Puppet in order to provision these images on different machines, different boxes. So again, it can alleviate some of the pain that comes with the Puppet manifests, like writing Puppet manifests, but you still need Puppet in order to send these to promote it to different stages. So yeah.
Thank you for the talk. I've seen that the images you downloaded were playing with the Bluetooth 12.10, and I was wondering if it is possible to actually run different operating systems in those, or do you need I assume you share it in the external. If I wanted to run one image of Bluetooth 12.10 and one 17.10.
Yes, you can. So we actually have CentOS machines that are running Ubuntu images. And the base image that I showed is not recommended to use anymore. At the time I was building the demo, it was, and so I just built it with the base image. But these days we have to use something else. And the public registry has a ton of different images that have different operating systems. So CentOS and Ubuntu are currently the popular supported ones, but I don't know about the other distros. It has not caused a problem. So we have a host operating system that runs CentOS and then an image which runs Ubuntu, but they can still share the kernel with the underlying kernel, so it hasn't caused a problem.
Thank you very much.